Hello, ladies and gentlemen. This is part two of the density topic that we're covering within Prologue. I decided to kind of break up this section a little bit into two somewhat smaller clips instead of having one massive one. So enjoy the rest of the show. Thanks a lot. A couple of facts about density and some things that make your life a little bit easier. The Regents likes to play these little tricks occasionally with these density word problems, and this is one thing that they like to do that will actually make your life easier. Density facts. The density of a substance remains the same regardless of the size, shape, or mass of the sample. It does not matter if you take an aluminum bar and you cut it in half and half and half and keep cutting it in half as many times as you want. The density of that aluminum bar will always remain 2.7 grams per centimeters cubed. Those individual pieces will always have a density. Their mass may change, their volume may change, their density remains the same. The density of aluminum is the density of aluminum, which is 2.7 grams per centimeters cubed. Okay? And this is just basically reiterating what I said here. Okay? So here's our aluminum bar. Got it? Density equals 2.7 grams per centimeters cubed. I took that aluminum bar, I cut it in half. Here's my other piece right there. And guess what? This piece also has a density of 2 grams per centimeters cubed. 2.7 grams per centimeters cubed. Hasn't changed. This one equals that one, which equals that one. A couple of other things. Water and density. Most natural substances are densest in their solid phase. Most things. So if you look at gold, silver, platinum, titanium, carbon, it really doesn't matter what it is. In their solid phase, they're going to be most dense. There is one exception. Water is most dense or more dense as a liquid and less dense as a solid. Okay, so water is the one exception that we have to worry about, but we do deal with it quite a bit in earth science, so it's one of those that you're just going to have to remember and know. This is because as water freezes, it expands, or its volume increases. So its density is going to decrease. Okay, this is one relationship we'll look at again, but as the volume goes up of a substance, the density will decrease. Okay, ice floats because it is not as dense as the liquid that it's in. Most of the time, water itself. Remember, the ice as it freezes expands, its density drops, and it becomes less dense. Less dense objects float. Okay. The next relationship that we're going to look at, as pressure increases, the density also increases. Let's think about what happens here. Remember, density is nothing more than how much matter is packed into an area. So if we increase the pressure or squeeze on that object, we can put more matter, increase the pressure, puts more matter, whoops, sorry about that, increasing matter, puts more matter into a volume, but its mass remained the same, so it increases its density. This is a direct relationship. Okay, temperature and density. This is a big one. And a lot of people get this confused pretty often. Okay? As our temperature increases, okay, our density decreases. This is an indirect relationship. So we can put temperature along the bottom here, our independent variable, our density here, and we would get an indirect relationship. As our temperature increases this way, our density decreases. Okay, this is an indirect relationship. What this is saying basically, as we take air and increase the temp, the density of that air will decrease. Okay, we'll talk about that again right here. Okay, so what ends up happening is that warm air will rise to the surface or go up. Air acts as a liquid, so it doesn't matter if we're talking about air or water. Warm water will also rise to the surface. Warm air rises to the surface. When it gets up, hits the surface, and it eventually cools down. And when it cools, it becomes more dense. So density increases here, and density decreases right here. So it rises up, comes back around, forming what we have a convection cell. So when you go into fires, the warm air and all that smoke is up on here. The density is down here, but the temp is up. And that's why it's up here. So they tell you to get down to the floor. Okay, hot air balloons work off the same principle. Basically, what we have at the base of this hot air balloon right here is we have a little flame. It's my little fire right there. And what it does is it heats up the air. As it heats up the air, the temperature increases. The air inside, the volume expands. The volume increases, pushing out in all different directions here. So the volume increases. Our density is going to decrease, and balloon goes up or floats. The hotter you get that air, the more that the air pushes out and exerts out onto the sides of that balloon, the density decreases and goes up. That's how they control the height or the altitude of that balloon, by controlling that flame. So that pretty much wraps up density. I know it was pretty quick, but you can go back and watch this a few times, or just certain parts, and the same with the problems. And I hope you enjoyed it. I will talk to you next time, finishing up the prologue with some a little bit more math. And that's it. Have a good day. Goodbye.